All right. Welcome to the Daft Contributor Sync. Today we have a pretty exciting agenda. We're going to talk about all the highlights of Daft in the last month or so. But to kick us off, why don't we start with Colin? Colin, why don't you walk us through some of the highlights of Daft over the last month?
Yeah. So, at Daft over the last month, we had quite a lot of new things going on, all across from, new kernels, new data sources to read and write from, and even a new website. And so I think what would be pretty interesting if we start off on the website and then from the
Let's do
website,
it.
yeah, let's start from the website. And from the website, we can see in the documentation what exactly did we come up with for the past month. So
Yeah.
yeah, this is our new getdaft.io website. Very nice, very nice.
Yeah, I feel like we almost need like a wayback machine, like what do you call it, the archive machine to go back and see what the crappy old one looked like. Yeah, the new and revamped website. I think with really nice capability section that I really like, and also this use case section, which I think we need to do a better job of. Still, I really want to see like outputs at the bottom. But yeah, it's like the main use cases that we've seen people use Dash for. And then also all these links are clickable. And so like all these integrations that we do, you can click on them and it actually leads to a nice page in the DAP documentation, right? Where we talk about how do we actually integrate with, AWS, for example.
Yeah, I guess. Okay, next up, read SQL. Yeah. Jay, you want to go back to the website actually? Maybe we
Yeah,
can the read SQL documentation and then see what it's all
down
about.
here.
And then Daft user guide, or you can do that as well. Yeah. And then I believe it's reading and writing and basic and concepts. Yeah. And then from databases.
Databases.
Got it.
Nice.
Yeah, so in addition to all the variety of data sources that Daft currently reads from, we have Parquet files, CSV files, S3. Now you can read from SQL databases. So we support a variety of databases, Postgres, MySQL, Trino, SQLite. And this is mainly due to the backends that we use in order to read these SQL databases, namely Connector X, which is a really good Rust-based SQL connector. Um, that one supports all the main ones, Postgres, MySQL, even BigQuery, Redshift, things like that. And there's also the good old SQL Alchemy, which is the Python, universal API to read any SQL database. And that one gives you, basically the whole shebang of SQL databases. But we didn't just make read SQL to be, your average SQL reader. As with Daft, which is a distributed query engine, that read SQL can also read a SQL database in a distributed fashion. And we do some pretty neat tricks to do this. Suppose you have a column of dates, and you know that you want to partition, you can partition your table on these dates. So what Daft will do is it'll actually take percentiles of the dates in your date column and use a where clause to distribute SQL queries across these partitions. So for example, like partition one will read data from January 1st to February 1st, and partition two will read data from February 1st to March, and so on and so forth. And yeah, that way you can get really efficient reads into um, distributed partitions.
Yeah, that's super cool. Because I feel like a lot of engines, when you query a SQL database, it just kind of does it all in one like machine or one process, right? And then it takes all this like gigabytes of data and spreads it over the cluster. But if we're able to do this partition reads, that makes for really, really efficient reads of data from the database.
Oh yeah, and like without any like JDBC things like that too.
Oh
It's all
yeah. Yeah, super, super cool. All right, what's next on the list?
yeah.
But how about we talk about our kernels first, Colin?
Yeah, and so yeah, new kernels, basically, new functionality on DataFrames. You can do things like rounding numeric columns, getting the sign of them, doing trigonometric functions like sine, cosine, tangent. Yeah, and the nice thing about all these new kernels is that most of them were contributed by non-Daft maintainers, so actually community contributions, which we're really happy about because they're really picking up.
Yeah, big shout out to I think Murex, right? Sherlock Beard.
Sherlock,
Who else? Who else did we have that was
people,
really cool?
people win.
Meepo Win, yes, really, really cool PRs coming in from Meepo Win. Yep, very cool. Yeah, I think that like people often overestimate the amount of work that needs to be done for us to get to Spark parity. It's like this stuff really just kind of came in over the course of what, a couple of days,
A day.
right? Yeah,
Yeah,
and like honestly, like I don't think we're that far off in terms of functionality versus something like Spark or Polars
yeah.
for like these scalar kernels, which are very easy to implement.
They are pretty easy to implement. I feel like the abstractions that we have in our code really allows it to be pretty easy for anyone to implement these kind of scalar kernels.
Yeah, so I guess like the takeaway is also for anyone out there, if you're looking for like a good first task to get started working on Dafton, it's one of these, right? Round, sine, trigonometry, string match, string replace, and yeah, Colin, why don't you show us where you can find that on
Yeah.
the issues page?
So if you go down on the
Mhm.
on the Daft main page, all the way down, no,
So this one,
yeah, Daft main page, all the way down to the contributing section, up a bit.
contributing. Here we go.
Yes, there's a list of good first issues right from there.
Beautiful.
Yeah.
Yep, and it's all these expressions. Look at them, all ripe for the picking.
Yeah, and they're coming in pretty quickly.
Yep. Okay. All right. I guess we're getting to the meat of today's discussion, which is data catalogs. Let's talk a little bit about some of the new functionality coming in for the data catalogs.
Mhm.
Number one on the leaderboard, we have rights coming in for Iceberg. I think this is actually really cool. Let me maybe pull up the PR. Yeah. So this PR adds the ability to do dot write Iceberg here. So
Mhm.
yeah, this basically gives us the ability for any data frame to write to an Iceberg table. And right now we support append and also overwrite. So kind of two modes of operations, right? So append, well, it's a strictly additive operation in your Iceberg table. We just add to the end of the table. And then we are also able to just like overwrite the entire table. We're just like, hey, like I'm done with this table, like delete all the data, replace it with the data now that's in the data frame. I think what's cool about this is that we are actually just leveraging under the hood PyIceberg to do it. And so if you're already in the PyIceberg ecosystem, in the Python and Iceberg ecosystem, this works super, super well with the official SDKs coming in from Tabular, people that maintain Iceberg. And yeah, it just uses a lot of functionality that PyIceberg provides. But what's cool is that we do this in a distributed fashion, right? So Daft is super optimized because in a distributed setting, we are able to efficiently write the data out, and then we use PyIceberg to do a commit. And so we don't actually go through PyIceberg for the data path. And that makes it super efficient because we have really optimized ways of writing and reading from S3. So we do all that. And all we need to do is tell Iceberg, okay, like we're done with the writing of data. Here's the data that we wrote, and Iceberg will do the commit, which I think is really cool. Where we want to bring this, right? If you go to our Iceberg user guide and you go down to kind of the roadmap portion, right now we are able to write to these Iceberg tables. The problem is we're not able to write yet to partitioned Iceberg tables. And that's because we right now it's actually just a limitation of the PyIceberg library. Daft itself already does partitioned writes, but PyIceberg itself is not able to handle it. And I think within the next month or so, they should add that back in, and we should just automatically be compatible, which is very cool.
Mhm. Oh, that's gonna be sick. Yeah.
Yeah, cool. And then the next thing on the list is Hoodie. We are getting Hoodie support contributions coming in from the folks over at I think OneHouse is the company name that maintains Hoodie. I think the funny thing is actually all the code for their Python client for Hoodie currently lives in Daft
Okay.
after these contributions. So if you go down to like the Daft and Hoodie, this PyHoodie folder actually houses the entire like Python implementation of Hoodie right now in the world. Like it only exists here in Daft, which is kind of funny. But yeah, so we're able to utilize this Python API in a Hoodie scan, which was implemented by the folks over at Hoodie to allow Daft to read from Hoodie. And I mean, the file itself is only like less than 200 lines long, which is consistent with our other implementations. Once you have kind of this Python client that we can read from, and so it's actually really easy to build these integrations with these different table formats.
Well, yeah, the scan operator was definitely really helpful for building read SQL. It was super easy.
Yes. Oh, yes. We should maybe like show a little bit of that, which is let's see, read SQL. Yeah, the SQL scan too is down here, right? It's a little bit of a longer file, but the main idea is just it's this scan operator which
Mhm.
allows Daft to then read data from these various sources, and scan operators have very specific jobs. Specifically, what it needs to do is it needs to produce this iterator of scan tasks, which the Hoodie reader does. The SQL support does that as well. And then even like if you just read from a file system and there's just like CSV files, we have like a glob scan operator that will produce scan tasks for your file system. So
Mhm.
it's all kind of in here in like pretty concise code, which I find super cool. And then last of all, we have a little blog post from the folks over at Delta Lake announcing our Delta Lake support. So yeah, so we worked on a blog post with the folks over at Delta Lake, and we were able to demonstrate some really interesting results where we're reading this data over from Delta Lake, and kind of demonstrating data skipping optimizations, right, with Delta Lake's Z ordering, which is really cool. And then also a little bit of benchmarking, right, where you can see that if you read a pure JSON version of this data set versus if you read it from Parquet, where you convert the data into Parquet, it gives you about 25x faster reads, versus if you like put it into Delta Lake, there's some characteristics about this query that allows Delta Lake to outperform this pure Parquet by about 2x. So you get like 50x on top of JSON, which is really, really cool. And we also did some local benchmarks where we benchmarked against other query engines like Pandas and Polars and DuckDB, and we were able to see that like Daft does really, really well in this benchmark we're reading from Delta Lake, which I thought was really cool.
Yeah.
Yeah, that's it. This is the actual Delta Lake benchmark, and this is Parquet. Yeah, but yeah, check out the blog post. Super cool. I think we're really looking forward to doing a lot more collaborations with other folks in the community. Definitely the catalog folks. I think the big three catalogs, right? Iceberg, Delta Lake, Hoodie. We're looking to further collaborate with them, and then Colin, anything else on the highlights you wanted to talk about before we get there?
Mm. I think quick thing to mention about the Delta Lake stuff is that, now that we have Delta Lake support, it really enables us to do things like enable Unity catalog from Databricks,
Mhm.
as well as the AWS Glue catalog. So really nice support if you're already using Databricks or AWS Glue. Yeah, you can look forward to future reads from that using
Yeah.
Daft.
Yeah, super cool. I've also been toying around with Daft running on Databricks, which is really interesting. And so if you have a Databricks account, you can actually run Daft in your Databricks account, either a single node, right, obviously, or I found a way to run Ray on Spark in Databricks, and it's actually pretty straightforward to like run Daft distributed in your Databricks clusters. All you got to do is call this like a single line function to start running Ray, and then you just do like Daft connect Ray, and like bam, you're off to the races. You're using your Databricks cluster for Daft, which I thought was pretty interesting. Yeah, so with this Delta Lake support, actually, we're able to also work pretty nicely on the Databricks platform because I think all the data on Databricks is just kept in Delta Lake tables. And so if you access the Databricks Unity catalog or the Hive meta store, those are all under the hood backed by the Delta Lake table format. And so yeah, Daft can now read all that data pretty easily. Yeah, but I will say though, I ran into some issues with like our APIs for accessing this type of data, and I think we'll go a little bit more into that in the deep dive for the data catalogs. But yeah, I think there's so much potential for Daft to be building good APIs for the stuff with regard to like setting default catalogs
Mhm.
or just specifying names of like tables in the catalog without like creating these like Python objects.
Mhm.
And also just like generally, I think authentication was also a little bit of a pain in the Databricks environment, and also Databricks has its own file system that we need to consider. And so I think there's a lot of really interesting things we can do there to make the user experience really good with data catalogs in general, which I'm pretty excited about.